All right, welcome to video 12. We're going to talk about limits, whether they have to be factored or expanded or use the conjugate or simplified in general. All right, and this is the 12th video. And again, we're going to go quite fast. So if you want to try these, that's great. I have 6 examples on the board. And the first one up here, often students see this as a conjugate problem, number 21. When I look at this, I actually remember that any difference, the numerator can be factored. So if we expand this, what I see with 21 is that we could write 9 minus t as 3 minus the square root of t times 3 plus the square root of t. And again, if you see that factor, what happens is the denominator cancels. And again, you should plug 9 into the denominator to see it's 0. You put 9 in here and you'll get the answer as 6. Often students don't see that. What I see is that they usually see the black and green in here in this step. And they multiply by the conjugate, which is another step. Again, plug in the value, factor, or expand it. If you can't do that, try conjugates. In this case, the conjugate creates 9 minus t on the top and bottom. And again, you plug 9 in and you still get 6. All right. So now, like I said, if you know what you're doing, and this is really for practice, for review, go ahead and grab these. On number 22, I see this function. Again, you plug in 0 at the bottom, it's 0. I see this as a root function, guys, as the square root of x from 1 to 1 plus h. And again, we're going to pull the point q back to p. But again, you don't need the graph to do these. Now, in this case, we do need to multiply by the conjugate of the numerator, which is just changing the sign between the root and the 1. When you do that, you get this in the numerator, 1 plus h minus 1. The 1's cancel, and you got h over h, which means the h is canceled. And moving down the board now, you have 1 over, and I got a little dot there, but it's 1 plus h. So you plug 0 in here for h, and you get 1 over square root of 1 plus 1. Guys, we get 1/2 for the answer for number 22. All right? Number 23, and again, you look at it, you think to yourself, well, this has to be a conjugate probably, because you plug 7 to the denominator, it makes 0, and the top has a root. So I multiply by the conjugate, which just has a 1 sign changer, plus 2, right? Or plus 3, I mean. And you multiply the conjugates, a squared minus b squared, so I get x plus 2 minus 9, which means minus 7. And x minus 7 over x minus 7 makes 1. Now we plug in the 7 right here for x. You get 9 square root of 9 is 3. 1 over 3 plus 3 is 1/6. All right. And again, I'm going quite fast, assuming you've learned this. Again, the left hand and the right hands are both equal. We're not checking it because we're able to prove it. And then 24 is tough. You plug in 2 in the denominator, it doesn't work. You can't expand it, so this has to factor. And I hope what you see is that 2 makes the top 0 also. Guys, and 0 over 0 is not an answer. It's not 0. So I know that x minus 2 is a root of the numerator because that goes to 0 when you plug in 2, and that means it factors. And I don't want to take time with it, but I'll do a polynomial division down here. And that means I can put in x cubed plus 2x squared plus 4x plus 8. And now that this cancels, I can cancel this, and I plug 2 just into that polynomial that's remaining. And you get 8 plus 8 is 16, plus another 8, 24, plus 8. And everybody, this is 32. And again, it's just seeing the values here, guys, okay? The last 2 are more complicated. You look at them, and I'll tell you right away. You can't have multiple terms. It's going to have to get 25 has to get something. You plug in -4 in the denominator, it doesn't work. So the first thing we have to do in the numerator is make those 2 terms into 1 term. And we do that by doing some addition with common denominators, 4x being the common. And then what I get here is I can divide these out, right? And I can get 1 over 4x. I can plug -4 in now. I get that this is -1/16 for a limit. And again, you can do this through simplification, factoring, and cancellation. 26, the same thing. You have 2 terms. You really have to have a single term to evaluate limits. So the first thing I do, always factor first, guys. Get the t out of there. That's what I do in step 1. Then the common denominator is t over t plus 1. When I do that, the 1's here cancel. I have t over t, which turns into this, and I plug in 0. 1 over 1 is 1. Again, conjugates are the third step. Remember, we're going to plug it in, the limit first, to direct substitution. Then we look to factor or expand. Finally, we do the conjugates. And the last step will be graphing, guys. We've always got to make a graph if it doesn't check out. Limits, you just need to practice.